Now, certainly, just as the research space often yields results we can't predict, so does the technology space. Who would have believed a few years ago how integral these would be to our everyday lives? Even more than that, imagine just 1 year ago. Who would have believed that these were not only great for content consumption, but also content creation? In fact, if you remember our demo last year, you saw that content creation on one of these devices is not only possible, but extremely powerful. And while no one could have optimized a language more than 26 years ago for touch technology, we certainly know now that LabVIEW is the most touch-ready language on the planet. Now, to share with us our current mobile and some future mobile and cloud technologies we have in store for you, please join me in welcoming Kyle Gupton.
Hello, Shelley.
Hey, Kyle.
How are you doing this morning?
I'm doing fantastic. How are you?
Good. Very comfortable up here.
Fabulous.
So one of our goals is to enable you to use technologies like tablets, smartphones, and the cloud in the most productive way possible in your systems.
Kyle, could you explain why we're on the couch here on the stage? It's nice, but...
Oh, of course. So one of the really great things about these technologies is that you can use them from wherever you happen to be. So if I want to, say, view data coming from an embedded monitoring system on my iPad here, I can do that from anywhere. I can either be right next to the system or halfway around the world on a comfortable couch in my favorite coffee shop.
Or on a random couch on a keynote stage. Thank you, Kyle.
So we see many applications for mobile devices in measurement and control systems. From viewing measurement data stored in the cloud, to configuring embedded hardware systems, to learning STEM concepts, or simulating circuits. There are many applications in this space that can take advantage of these technologies. For the past year, we've focused mostly on two key use cases: mobile HMIs for embedded systems and portable measurements. We've released two applications that are available now: the data dashboard for LabVIEW and the CDAC 9191 data display. These are available for both iOS and Android tablets and smartphones, and we're working on a version of data dashboard for Windows 8 tablets later this year. But today, I want to show you our latest software developments that move us significantly closer to our long-term vision of a whole ecosystem of applications and virtual instruments running on mobile devices that are connected wirelessly to NI hardware and also to the NI Technical Data Cloud for data transfer and storage. And of course, as always, at the heart of this vision is LabVIEW. For our demo, we've created a dashboard for the Ceres Solar Energy Monitoring System that you saw earlier today. That system is actually publishing data directly to the cloud, and I can visualize that data from the cloud here on my tablet.
So, Kyle.
So yeah, so if I...
Can you show it to us?
Absolutely.
That'd be great.
So Mark Kubis, the architect of the system, he emailed me yesterday the dashboard that he created. So I've gone to my email in my iPad here, and I'm going to open up the dashboard here on my application and run it. And we see a really nice image of Singapore here for a splash screen. And as I swipe to the right, you see a map of Singapore overlaid with the solar irradiance measurements being made. And I created that all right here on the iPad.
So this is a very fancy, all pre-done user interface. Can you show us how you actually build one of these data dashboards?
So let me add a new page here to the dashboard. So I'm going to go and I'll add a new page. And what I want to do is I want to read one of the irradiance measurements directly from the CRIO now instead of the cloud. So I'm going to do that by using what's called a polling web service. So I'll drop the polling web service, and when I configure it, I browse to my compact RIO system that's publishing the web service, and I choose the one that publishes the data. And you can see that it outputs 13 different irradiance values. So I can select one of them and bind it to a control. So it'll allow me to create a new control, and I'm actually going to choose a gauge because that's one of my favorite controls in here. And then I can configure the gauge to have a data range appropriate for my application. And then also I'm going to change the theme to make it look really nice. And so
a really nice gauge.
It is a really nice gauge. And so when I run the system, you can see that it's updating with the current solar irradiance values.
That's very cool. Of course, you know, and I think many in the audience know, that we like to try to show on day 2 really some more forward-looking demonstrations of technology. Now, you said this new data dashboard will be in the App Store very soon. So do you have anything that's a little further out, a little more futuristic that you can share with all of the NI Week attendees?
Well, of course. So one of the things that we're working on back in our labs is really trying to figure out how to make a fun and very productive touch-based interface for LabVIEW diagrams. So what I have here is one of the avenues that we've been pursuing, and this is a very, very, very early version of LabVIEW. Many varies, more than I can say here.
Those of you in the back, it even says not even a developer preview, so very, very, very early.
So the idea with this implementation is that we're using the automatic diagram layout algorithms that we introduced in LabVIEW a few years ago for the diagram cleanup. So here we have a diagram, and I can pan around and zoom with my fingers.
Are you zooming on a LabVIEW block diagram?
I am, on an iPad.
On an iPad, with your fingers.
Indeed. If I click on a node, it shows me the various terminals that are available. Now, to show you what wiring is like, let me load up another VI that I'm going to complete. So as I wire up this VI, you can see that the diagram starts automatically laying itself out to be neat and clean, and keeps me from having to go in and manually manipulate all of the nodes and wires, which would probably be pretty difficult on a platform like this. And of course, as you should, you do have undo, and it's nicely animated, and I can redo the actions.
And zooming and
this is a very fun thing. So I'm really enjoying
just
playing
keep doing
around.
It never gets old.
I know, it's, yeah. What is that?
This is an interesting coffee shop.
It is. I'm familiar with that music.
You are? I think I've heard it before today.
I think so.
Oh.
All right.
Hey guys.
Hey Jeff.
You've never come back.
Data dashboard is really looking great. And
Well, thanks.
seeing a diagram on the iPad, it's really exciting. I've been thinking about the same problem too, and trying to imagine what a good way to edit on the iPad would be. While playing Angry Birds one day, it hit me that...
Not at work.
It hit me that there's an awful lot of computational power and graphics on the iPad, and we ought to use more of that while we, edit. And so I've been playing around with this idea that I call a physics-based editor. And so the idea is that there's a physics engine running, and it's calculating forces and updating velocities and positions, and I'm trying to figure out what's the best laws of physics that will make my diagram stay neat and compact. And so after a lot of experimentation, I came up with the idea that a repulsive force between the nodes should be short range and act like a foam padding around the nodes, so that if the nodes get too close, the foam gets compressed and pushes the nodes apart, but as soon as they're apart, the force goes to zero.
That's really cool.
With the physics engine running continuously, I can see how that my layout's going to adjust dynamically in real time as I move things around. I also added a force that makes nodes move to the right of the ones they depend on, so that forces a left-to-right data flow that we like so much. The most challenging part of this, though, was getting the wires to do the right thing. Basically, the neighboring joints on a wire act like a spring. They attract each other with a force that's linearly proportional to the distance. But I figured I needed to add a short-range, nonlinear force in order to get rid of those little jags in the wire, which is so annoying on the diagram. So it seems to be doing pretty well. And an interesting side benefit was that the diagram actually stabilizes in multiple arrangements. And I find that appealing because there are times when I prefer one layout versus another, and that wiring helps it.
Nice. So what about structures?
Well, I thought of that too, and if I add structures to the mix, basically, they're just a box, and the box tries to contract to some minimum size, and nodes inside it will repel the boundary just like they repel each other with the same short-range force. But the boundary of the structure has inertia, so that if I drag a node fast, it'll go past the boundary. And in fact, you can see as it approaches the boundary, it repels, and then on the other side, it repels from the other direction. And so there's this little bounce.
Oh, nice.
Kind of a nice physical effect. And I didn't have to do anything extra to get that to happen. It was a natural consequence of the physics. So then I started playing around with the idea of moving wired nodes in and out of structures. And
Yeah, that's good.
so once I had done that, then I thought, well, maybe I could leverage that same live dragging to do wiring. So I tap on a node to show the plugs, and I drag a plug from there to a socket on another node. And because the plug was a node, it dragged across the boundary just like all the other nodes. I didn't have to do anything special to get wiring across boundaries to work. And I can use the same gesture to drag the plug off the node, and I could wire it to something else, or I could just leave it around. I kind of like having a plug around instead of a broken wire. So the next thing most recent thing I was starting to experiment with is, could I shrink and expand things in place and get the diagram to relay out nicely, behave nicely. So I started experimenting with that, and it seems to work
That is
really
awesome.
well.
Very cool. So Jeff, with all of your experiments and playing in code, what do you think is next?
Well, I think the idea of a physics-based editor has merit. There's a lot more to figure out, working with larger diagrams and refining the laws of physics so it converges rapidly and so on. But I figured you'd be interested in seeing what I was up to.
I think we all love to see what the father of LabVIEW is still programming himself in the lab. So thank you. Thank you both for coming up here.